All right, welcome and thanks for joining for the 4.5 examples. We're going to jump in right now. It might be a little bit long because sometimes those graphing questions. So find the amplitude of the following trig function. So just looking at solely amplitude. When we're talking about amplitude, we're talking about the absolute value of the coefficient. So here, a is equal to 2. Remember that what the amplitude is really telling us is the distance between the center of the trig function and the maximums or minimums. So it's 2 units from the center to the top and bottom of this sine function. Here, a is not -6, a is just 6 because it is the absolute value of the coefficient. So this is sort of like a vertical stretch, going back to section 1.4. The negative represents a reflection. Here, a is 2/5. So that's sort of like a vertical shrink. I'm only going to go 2/5 up from the center and 2/5 down from the center. And here a is +67. Again, just that idea of the absolute value. So amplitude is going to be one of the things that we're going to need in the graphing. Another thing that we're going to need is the period of the function. So let's start by just listing the amplitudes again. Here a is 5. Here a is 3. Here a is 11. And here a is 7. And again, that's coming from the absolute value of these coefficients. When we're talking about the period of our function, the period is going to come from the type of function itself. So sine, cosine, sine again and cosine, those have a basic period of 2 pi. However, the overall period of the functions is 2 pi over the absolute value of b, where b represents the coefficient of x. So here for my period, I would have 2 pi over 2, which means the overall period for this function is actually just pi. 2 pi is for a basic, like an unaltered function. Here, period is going to be 2 pi over, the coefficient of x is 1/3. So this is 2 pi over 1/3, which is really 2 pi times 3/1. When you divide by a fraction, you multiply by the reciprocal, which gives me 6 pi. Here, the period is 2 pi over, and my coefficient here is pi/6. So again, I'm going to multiply by that reciprocal. So 2 pi times 6 over pi. The pi's cancel, so my period here is just 12. And here I have 8 pi, so p is equal to 2 pi over 8 pi, which is 1/4. So this is taking it a step further now. We're not just looking at amplitude, we're looking at amplitude and period, because those are going to be the two things that are really going to be sort of quintessential for the graphing of these trig functions. So let's get to a graphing one. Y equals the sine of 2x. The first thing we want to start by noting is the amplitude. The coefficient on sine here is 1. And the period, so the period is 2 pi over b. So 2 pi over 2, which gives us pi for the period. When we are sketching these, the order of our x values, so we're going to talk about two things, x and y, same thing like we did with logarithms, and I'll fix that because that was a really bad line. That's also a really bad line. Let's try this again with just a straight line tool because I'm really bad at making straight lines. When we talked about logarithms, we set up these tables, and that's the same thing I'm going to do with trig functions as well. The way that the x values work is it goes from 0, and then you're going to skip some space, to pi. The midpoint of these two things, so this was pi because that's what the period was, 0 to the period. The midpoint of these is pi halves. The midpoint of these is pi fourths. And the easy way to get whatever is here is it's always 3 times this one. So you multiply that by 3, and we get 3 pi fourths. In terms of my y values, those come from sine itself. So sine, if you think about the shape that sine has, goes 0, 1, 0, -1, 0. Those are its sort of important values. So sine 0, 1, 0, -1, 0. This is stuff that you have to remember. And that's going to be my y's, 0, 1, 0, -1, 0. We then look to the function and say, well, are there any changes? Amplitude is 1. So, I'd be multiplying my y values by 1, so that's not changing it. The period is pi. That is a change. However, we already dealt with it. We naturally deal with that. And there's no other changes to this. So I can go straight to the graphing now. When we sketch these, we are going to do 2 full periods. So what we're going to do is go to negative pi to positive pi. And we'll label all these things in between first. You do have to make sure that you're labeling all of this. It does get really tedious and really annoying, but it's so that we know that you're actually doing everything exactly how we want. Looking at our y values, those go from a minimum of -1 to a maximum of +1. And then you can start I usually like to start right here. So 0, 0, pi fourths 1, pi halves 0, 3 pi fourths -1, pi 0. So I know I have this shape. Again, that's a rough sketch. What you cannot do, and this is what's very common, is people sort of reflect this over, and that is not how this looks. What this is going to do is essentially you're going to pick up this whole thing and then just redraw it over here. So it's starting here, 0, 0, 1, 0, -1, 0. So notice sort of breaking it right here. That's where one period stops and that next period begins, because a period is how long it takes for something to be repeating. So right after I get to this, the whole function is now repeating itself. And we'll look at different ways, or I'll talk about different ways to sort of sketch that out. All right, looking at another one, we have y equals -3 cosine x. So first thing we want to talk about, the amplitude. The amplitude here is a +3. However, this negative tells you that there is a change in the y. So we're reflecting over x. The period is just 2 pi, because we do 2 pi over 1. So if I'm going to make my table of x and y values, we're going from 0 to 2 pi, with pi in the middle of that, pi halves in the middle of that, and 3 times this, which is 3 pi halves. Cosine, if you think about the basic shape of cosine, it goes like this. So it goes 1, 0, -1, 0, 1. Again, that's 1, 0, -1, 0, 1. This is something that you're going to have to memorize for cosine. So I start off with that 1, 0, -1, 0, 1. Then we need to adjust this for any changes, just like with a logarithm. This is just our basic stuff. Now the period, we already deal with that. That's naturally sort of dealt with. But the y value changes. Well, the amplitude is a change in y, and the reflection is a change in y. So essentially, if you're looking at this function, well, I take the regular cosine and I multiply it by -3. So this will become -3, 0, 3, 0, -3. And now I can go and do that sketching. So let's draw ourselves an axis. We are doing 2 full periods. So this period starts at 0 and ends at 2 pi. And I shouldn't have made this one actually a point. So this will be pi, 3 pi halves, pi halves, -2 pi, -3 pi halves, -pi, and -pi halves. This is going as low as -3 and as high as +3. What you can do is really start all the way to the left and then just go down this order. So I'm starting here, -3, 0, 3, 0, -3. If you do it this way, what you have to realize is this -3, you're not going to now go to this next one and say, oh, okay, -3 again. You're going to say, okay, I already have that -3. And skipping over it to 0, 3, 0, -3. You think about, you're sort of just running through this list, -3, 0, 3, 0, -3, and then coming back to the top and saying, well, I already did that -3 actually. Because that is, let's just draw this curve. That reason that you'd sort of skip over it is because the -3 is the end point for one period and the starting point for the next. So it's the same point. This is the end of this period and the beginning of this one, which is why you're not going to bow -3, then -3 again. This is my two full periods. You can sort of see it does repeat itself. It does look like it's just been shifted over on top of each other. All right, by hand, sketch a graph of y equals the cosine of x plus pi fourths. So at this one, the change that we're looking at, oh, well, let's answer the questions, I guess. Sorry, I didn't even look at what's being asked. The amplitude, 1. The period, all you look at is the coefficient of x, so 2 pi, since this would be a 1. There is a horizontal shift to the left. Remember that this is counterintuitive, and it's pi fourths. Remember that for horizontal shift, you do c over b, which is pi fourths over 1, so still pi fourths. Now, sort of pay attention to how I'm going to make this table, because I make it differently only for a horizontal shift, and I stress that, because I make a much larger table. When I make this table only for a horizontal shift, I say here's x and y, and I'm going to start here and say, okay, I'm going from 0 to 2 pi, then I have pi, pi halves, 3 pi halves. And then I have -2 pi, -3 pi halves, -pi, -pi halves. And you know, all I'm listing is everything that would be on like that number line. But I'm doing it very specifically for a reason. Now, if I also want to look at sort of just my cosine's y values, the cosine y values, if you think about cosine, it goes like that. So it's 1, 0, -1, 0, 1, 1, 0, -1, 0, 1. So 1, 0, -1, 0, 1. This is the end of one period and the start of the next one. So 1, 0, -1, 0, 1. There are no changes to y. There's just this change to x. So now, what I'm doing to my x values is shifting them to the left pi fourths. And this is the reason that I wrote them all out, is when we start dealing with these negative ones, that's where people make a mistake. Because what's not going to happen is you're not going to have the same numbers on the left and right. You're going to have more numbers on one side. So if I do -2 pi minus pi fourths, I get -9 pi fourths. You know, this is 8 pi fourths minus 1. This is 6 pi fourths minus 1 will give me 7 pi fourths. This is 4 pi fourths minus 1 will give me 5 pi fourths. This is 2 pi fourths minus 1 will give me -3 pi fourths. And then negative pi fourths. Positive pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. And now I've adjusted all of my x's, But what you can notice here is that -9 does not show up in both sides. And if you accidentally include it on both sides, you're going to have sort of too much graph, or if you don't include it up here, you're not going to have 2 full periods. You're either going to have more than 2 periods or you're going to have less than 2 periods. So now when I make this, -9 pi fourths, -7 pi fourths, -5 pi fourths, -3 pi fourths, -pi fourths. I didn't really do that well to scale, so I apologize. Let's actually just move this over. I think I can move you. Yes, wonderful. I'm a wizard. Let's move that whole thing. Oh, no, you don't want me to move that? Thank you. Okay, 3 pi-4ths, 5 pi-4ths, and 7 pi-4ths. Okay, so I'm gonna do this, and then I'm gonna talk about the issue that people make. 1, 0, negative 1, 0, 1. Here's 1, here's negative 1. 1, 0, negative 1, 0, 1. This is the end of the period and the start of the next period, so 1, 0. There is nothing on the y-axis, and this is where people, one of two spots that they'll make a mistake. The first one is whether or not they double this point, like they put it twice. But the other mistake just with horizontal shifts is that they put something at x being 0. But x being 0 is no longer one of my important, quote unquote, values for this function. So you skip over that and go to the important value, pi-4ths. Negative 1, 0, 1. If you had something here, you would notice right away there's something wrong with your graph because you would get more than 2 full periods. And then you draw this, hopefully better than my art skills graph. That was really bad, sorry. So doing another one, sketch a graph of y equals, pi halves x minus pi. The amplitude here, 1. The period, 2 pi over the coefficient, pi halves. So that becomes 2 pi times 2 over pi, which means our period is just 4. No pi in that at all. Your horizontal shift comes from c over v, which in this case is pi over pi halves, which gives me pi times 2 over pi, which is just 2. It's counterintuitive, so this is to the right 2. Again, anytime I have that horizontal shift, what I do personally is make that giant column. I'm going from 0 to 4, the midpoint is 2, the midpoint is 1, times 3 is 3, and negative 4, negative 3, negative 2, negative 1. I'm shifting these to the right 2 units, so I will add 2 to my x's. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. This is a cosine function with no changes to the y values and no reflections to the y values. So cosine goes 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. Done with those x's. And now I can, just go straight to the graphing. I'm going to have more on my positive x. I'm going 1 to negative 1. I've got negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. No pi's in this at all. Then I just follow my y's. So 1, 0. There is something at 0 in this case. Negative 1, 0, 1, 0, negative 1, 0, 1. I went through that whole cycle 2 times and no more than 2 times, which is a good sign. Also, just sort of pay attention to how I draw these endpoints. You don't want it going like that because that's not what happens, and I don't want to see that. I want to see it hook back down because that's what's happening in the function. And these other ones, you can see me sort of hooking this back down. And the previous one to that, you don't see it as much, but yeah, it's hooking back up. And this one, it is actually just going down, but it's going to come back around. But there shouldn't be a hook on this one because it's a sine function. So let's do another sine function. 3 sine x plus 2. Amplitude here is just going to be that absolute value, so 3. The period, there are no changes to the x. There's no coefficient of x, so just 2 pi. And in this case, the only shift I have, because this is not in parentheses, is vertical, and it means it's going up 2. That's a change in my y value. So if I'm going to make that column, I'm going to make sort of a short one. I don't need as much of a long one because there's not a horizontal shift. My x values go 0 to the period, and then the midpoint of that, and 3 times this. My y values for sine, if we're thinking about a sine function, it goes 0, 1, 0, negative 1, 0, 0, 1, 0, negative 1, 0. So 0, 1, 0, negative 1, 0. And my changes to y, well, there's 2 changes. 1, the amplitude, 2, the vertical shift. What you have to think about is which one would occur first. If I were to put a number in for x, I would take the sine of that number, then I would multiply it by 3, order of operations, then I would add 2. So I need to start by multiplying by 3. And then adding 2. So these are my final y values. Now I'm ready to go and do that sketch. I'm going from negative 2 pi, negative pi, negative 3 pi halves, negative pi halves, positive pi halves, positive pi, positive 3 pi halves, and positive 2 pi. The y values I'll need are negative 1, positive 2, and positive 5. And this goes 2, 5, 2, negative 1, 2. So 2, 5, 2, negative 1, 2, 5, 2, negative 1, 2. Draw my curve going through all of these. And then just the last thing to sort of talk about, just that idea of amplitude. You know, amplitude is the distance from the center. Here's my center of my graph. My amplitude is saying how far up or how far down I go. My amplitude is 3 here, so my center was 2. I went up 3 to 5 or down 3 to negative 1. That's the idea of what the amplitude is telling us, and that's what like that center of the trig function is. All right, feel free to get started on some of those graphing ones. They are a little bit time consuming. There's a lot of places that you can go wrong, but it is very process oriented and very structured when you're doing this table. Once you get that process down, they can go relatively quickly.